So am I audible? Am I audible?
Yes, sir.
Okay. So let's complete our quiz part. And I hope that all of you are able to do all those things. So the first question, you want to use the computer vision analyze image function. Okay, you want to use the computer vision analyze image function to generate an appropriate caption for an image. Which visual feature should you specify? Tags, description, or categories?
Description.
What about others? So you need to get the caption of an image. So from which tag you are going to get the caption? That's the question. So what about others? What about others? So only one responded. Okay. Description. Right. The answer is description itself. So from the description tab, you are able to get those things. Next question. What is the effect of smart cropping option when using computer vision to generate a thumbnail? Okay, what is the effect of smart cropping option when using computer vision to generate a thumbnail? First, the first thing is the aspect ratio of the original image is maintained. The second option, thumbnail is skewed to fit the specified proportions. Third option, the region of interest is centered in the thumbnail. Which is the right option?
Third option.
Yeah. If you are enabling, so what about others? What about others? All of them are saying third option. Right. Third is the right option. Why? Because when we are enabling this smart cropping option, then automatically the region of interest will be captured, right? Oh, so where's my cursor? Sometimes I'm not able to see the cursor. Okay, so this one is wrong, this one is wrong, and this is the right option. Then the next question, you want the video analyzer to recognize colleagues in videos recorded from conference call. What should you do? The first option, create a custom model containing a person for each colleague with example images of their faces. Second, edit the conference call videos to include a caption of each person's name on their first appearance. Third option, embed the video analyzer widgets in a custom website that employees can access using their own user credentials.
First option, sir.
First option. So what about others?
No, it is third option, right? Widgets.
So the question is actually all about, they're asking about
Video analyzer.
video analyzer. And the next thing is that we need to recognize the colleagues, right? We need
Correct.
to recognize the colleagues. And in order to recognize the colleagues, for example, in our exercise, we need to train one face. And what is the thing that I have done there? I'm actually renamed that face. At the same time, inside the model, I'm able to get the name of that person and also the different images of that particular face, right?
Exactly.
So there we are following the first option, right? Create a custom model, or we can directly load the images of our colleagues, load the images of the faces of our colleagues, and you can train a person model. And after that, when we give the video, it is automatically going to detect all those faces. But in the
the
third
third
option,
option, if you see, video analyzer gadgets, that widgets that which you are, and when you are trying to log in with your own credentials, automatically the image that which is there in the system should able to load and should name the person.
yeah, that will surely rename the person. But my question is that whether we will be having the option for editing in that custom website.
Okay, the question seems to be little.
Right.
Yeah.
Because when you're sharing that widget in the custom website, the users can see that. Users can see that, but that users does not have the provision to train another faces. because they are not using the credentials, right? Are you able to get my point? So I hope that it's clear to you. So the first option is the right one. So you are good to go. Now, I think that the next module will be easy for you. Why? Because we have learned some basic things there. Okay, we have learned some basic stuffs there. So this module is all about image classification and detection. Have you worked with this image classification or image detection, object detection in your projects? Have you worked with image classification and object detection in your projects? So can I get the?
Yeah.
You worked with that, right? So can you? Can anyone name some of the object detection algorithms, famous object detection algorithms?
YOLO,
YOLO. What is the latest version of YOLO?
Tiny YOLO,
Tiny YOLO is basically used for the mobile devices, or the when we need to use these models in the edge devices, we can go with the tiny YOLO. And asking about this version. So basically YOLO V1, V2, V3 is there.
V5.
Now V5 is the latest version.
Yeah.
So basically, one of the algorithm is YOLO algorithm. Then what about another other object detection algorithms other than YOLO?
MobileNet,
MobileNet is actually image classification models. So have you heard about SSD?
Yeah.
SSD, then
SSD mobile.
RCNN, regional convolution neural networks. So these are the examples of object detection models. And when it comes to the case of image, the thing is that basically I'm actually working in this computer vision domain. Okay, I started in this domain from 2014 onwards. I have worked a lot of things in this computer vision domain. I am actually very passionate about this technology when compared to this NLP. But now I am very much passionate about this NLP too, because I know how to work with this with the application. I am able to get how these things exactly work under hood and how to integrate all these services in our application. So in this module, we are going to learn about how to create image classification or how to develop image classification and object detection solutions. So let me start with that. Here, you can see that we are developing a custom vision solution. So what do you mean by custom vision? Custom vision means we are creating the models. We are creating the models. In computer vision, they are using their own models. Okay, Microsoft is using their own models to recognize the objects, to recognize the to detect the image, to detect the objects, or to detect the faces, or to detect or in order to have this optical character recognition. All of these things are actually captured using their own models. But here we are creating our own models. That's the advantage. Okay, so in this module, we are going to learn about what exactly image classification and what exactly object detection. So these are the two things or the two areas that we are focusing in this module. So let's go to the first lesson, image classification. As the name suggests, we are going to give an image. Okay, we are going to give an image, and the system needs to tell what exactly that image is. The system needs to tell what exactly that image is. For example, if I am going to give the image of a cat, the system is saying that it's a cat. So we can say that it's a classification problem. It's a classification problem. So let me give you some insights on this. So in order to train your own models, okay, so basically when we talk about this custom vision service, it's not the computer vision service, it's the custom vision. Look at this name, custom vision service. With the computer vision service, we are not able to train anything. With the custom vision service, we are able to train our own models. That's the advantage. So you can train your own models. Okay, you can train your own models using the custom vision service. And for what type of problems we can use that? For the image classification problem and for the object detection problem. Image classification and object detection. So what exactly these are? First of all, you need to train a model. Okay, you need to train a model. You need to say, you need to train a model for recognizing apple and orange. Okay, apple and orange. You need to train a model for recognizing apple and orange. So what you need to provide? You need to provide so many images of apples and so many images of orange to the machine learning model. So after seeing these patterns, the model is able to understand how an apple look like and how an orange look like. Okay, once it is able to find the relationship, then we can take out this model, and to this model you can supply the image of an apple. And here the system is going to tell that it's an apple. If you're giving the image of an orange, if you give the image of an orange, the system is going to tell that it's an orange. So you can train your own models. You use your own images to train a model. Okay, use your own images to train a model. And after that, once you're able to get this model, you can use this model to predict the labels for the new images. That means for this new image, what is the label? Here, apple is the label. So you are going to train your own models. So in order to have this, you need to have two types of resources. One is the training resource and another is the prediction resource. So in language understanding also, we will be having two resources, ordering resource and the prediction resource. There also we trained language models. Here we are going to train our custom vision models. That's why we need to have these two types of resources, training resource and the prediction resource. Training resource can be cognitive service resource, or it can be the custom vision training. Okay, you can use any one of these. And for the prediction resource also, you can go with the cognitive service, or you can go with the custom vision prediction. As the name suggests, keep this name. So custom vision prediction is used for the prediction resource, or you can use the cognitive service. Custom vision training or cognitive service can be used for the training resource. So these are the resources that we need to first of all create in the Azure portal. Then what is an image classification? Okay, what is an image classification? Once you train your model with the images that you have, later on, what you can do? Later on, you can submit an image to the system. The system is going to say that it's an apple. If you're giving this image to the model, this model is going to say that it's a banana. If you're giving this image to the system, it is going to tell it's an apple. So in other words, what is this picture of? Okay, that means it is going to say that what is the object present inside this image. So this is called as, okay, for example, suppose in this image, I'm having apple. Okay, I'm having apple. So when we give this image to the system, it is saying that it's an apple. It's an apple. Okay, so let me give another image. In that image, I'm having one banana and I am having one apple. So what is the result that we are going to get? Can you say that? Can you say that? In the first image, you only have this apple. So it is going to give the result as apple. But when we give this image, what the system is going to give you? Can anyone say that? No response. Why?
Apple.
So apple, but along with that apple, one more fruit is there, banana, right? So it needs to give both of this information. Okay, it needs to give both of this information. So here the term comes multi-class classification. Multi-class classification. Okay, then multi-label classification. Two type of classification are there, multi-label and so this is the same thing. So multi-label means if our image contains multiple objects and we need to detect all those objects, then you need to select this multi-label. You need to select this multi-label classification. If our image contains only one object, then you can go with the multi-class classification. Are you getting my point? Are you getting my point?
Can you repeat it, sir?
Sure,
Please.
sure, sure. So let me take the by both things. So there are two types of classification. One is multi-class classification. Okay, one is multi-class classification. Suppose you need to detect cat versus dog. Okay, suppose you need to classify versus cat versus dog. If this is the case, then you need to actually provide so many images of cat. Okay, you need to provide so many images of cat, and you need to provide so many images of dog. Okay, and one thing is that you need to note that during the training, this image contains only cat. This image contains only cat, and this image contains only dog. Okay, this image contains only dog. Once you get this model, after the training, you are going to get a model, right? So once you get this model, you are going to submit an image, and this, suppose this image contains cat, and the model is going to say that it's a cat. Again, same model, if you're giving the image of dog, the system is going to say that it's a dog. What happened? My question is that what happened if your image contains both cat and dog? Then what will be the label?
We'll need to multi-label then.
Right. That's the thing that I need to emphasize on. If you're going with multi-classification, you're only able to get a single label. Okay. If you are having multiple objects in a single image, for example, if you have this cat and dog in a single image, then you need to go with the multi-label classification. Multi-label classification. That means inside a single image, you will be having multiple objects. But with the multi-class, we cannot do that because we are going to say that in an image, only one object is there. That's the difference between these two types of classifications. Is that clear?
Yes, thanks.
Okay. So let's move forward. So how we can train an image classifier? That's the thing. So basically, if you are familiar with this TensorFlow, PyTorch, this type of frameworks, you know that first of all, you need to have the data set. Then you need to use this framework. You need to use the models, or you can use the pre-trained models for transfer learning purpose. There are so many things that we can do with this TensorFlow. Okay, so there are so many networks, CNN networks available like VGG. Then ResNet, so many networks are there. But when it comes to the case of custom vision, it's so simple. We'll be provided with one portal. Okay, we will be provided with one portal where we need to upload all the images and simply click this train button. It is going to train the model with the images that we have given. And finally, you can test your model by giving the images in the portal itself. This is one way in which you can train your model and test your model. And another way is that you can use the API or SDK. You can use the custom vision API or SDK. So if you're using the custom vision API or SDK, then you need to create a project using the SDK. Okay, or you can retrieve an existing project. If your project is there inside this custom vision portal, you can directly retrieve that existing project. You can do that. You can create your tags or retrieve the tags already present in this custom vision portal. You can do those things. Then you can upload all the images, tagged images. Tagged images means during the training, we need to teach the machines that this is an apple, this is an orange. Like that, we need to tag the images. So you can upload the tagged images, and finally you can train your model. So this is the approach that we are using in this image classifier. So basically, we are going to learn about how to create a classification model and how to use this custom vision SDK, and along with that, how to use this custom vision SDK for the training and the prediction resource. We are going to learn about that. So what is the difference between image classification and object detection? Can anyone tell about that? What is the main difference between image classification and object detection? Image classification and object detection. Can anyone say that? No one? Are you able to hear me? Are you able to hear me?
Yes, yes.
Okay, so let me tell you the object detection also. So object detection means, look at this here in this image. Sorry, I have changed my cursor. Okay, here in this image, you can see that multiple objects are there: apple, orange, and banana. If you're using multi-label classification, okay, if you're going to use the multi-label classification, by giving this image, it is going to give the result like it contains apple. Okay, it contains apple, it contains orange, and it contains banana. It contains banana. These are the things that you're going to get if you're using multi-label classification. But you're not going to get the exact location of that objects in the image. Okay, when you're using image classification, you're not going to get the exact location of that particular object in that image. But if you're going with the object detection, as the name suggests, object, we are going to detect that in the image. So here, along with the label, you're going to get the location information. This is the bounding box information. That means within this bounding box, we are able to find an apple. Okay, with this, within this bounding box, we are able to find an orange. Okay, so this object location is also specified here. So how we are going to get the object location? I told you that you need to have the x and y. That is the top left part. Okay, top left part, and along with that, you need to get the width and you need to get the height. So you are going to get the top left, width, and height. This is the official way in which, along with this apple, you're going to get the location information. Along with the orange, you're going to get the location information. Along with the banana, you're going to get the location information. Is that clear? Is that clear?
Yes.
Okay. Then
One more thing, in detection,
right.
we also associate the labels as well,
Yeah.
and all the coordinates as well.
Yeah, sure. In the detection part, we are going to get the, so basically there are different terminologies we are using in image classification. Once we give the image of an apple, you're going to get the information like it's an apple. So it's a tag. In object detection, apart from this tag, you're going to get the object location also. Okay, so apart from this tag, you are also getting this object location. So all of them can be treated as a single label. Is that clear?
Yes, thank you.
So here also we can use the custom vision portal. The same approach, we can use our portal for training our models by submitting the images, or you can directly use the custom vision API or SDK. So if you're using the custom vision API, what is the strategies that we need to give? You need to actually create a project, then create the class tags. And for each of these images that we are going to train, we need to specify the bounding box information with the corresponding tags. During the training purpose itself, what we need to do? During the training purpose itself, if some objects are there, we need to provide this information during the training. Otherwise, how the system is going to learn? It's a supervised type of learning, right? It's a supervised type of learning. During the training itself, we need to train that actually in this image, this apple is located at this point. So you need to actually, for each of this image, you need to provide the bounding box and the corresponding tag information. Okay, once it is trained, you are able to use this model for the prediction. So basically, when it comes to the case of labeling images, okay, when it comes to the case of labeling images, in the custom vision portal, the things are little bit different. So what is that difference? For example, you can see this image, right? You can see this image. Look at this image. When you see this image, inside this image, you can see that an apple is there and also a banana is there. So two things are there. And for this apple, this is the information. So the tag is apple. What is this left top? Can anyone say that? What is this left top? What is this left top? Can anyone say that? What is this left and top? This is the coordinate position. This is the top left coordinate position, but it is written like 0.44 or 0.15. What is the meaning of that? The meaning is that, please listen to this. Here, this image is having a width. Okay, here the image is having a width. Say 80 is the width, and here the height is say 60. Okay, 60 and 80 is the width and height. Okay, this is the height, and you're going to say that 0.44 left. Okay, 0.44 left. That means, please listen to me. 0.44 means this 80 needs to be multiplied with 0.44. Okay, and you're going to get a value. That, okay, once you get that value, you need to move from left up to that point. Okay, you need to move from left up to that point. Then here, you're going to get the value 0.15. 0.15 means you can take the height 60. So 60 into 0.15, you're going to get that value. Okay, from the top, you need to come up to that point. So this is the top XY. This is the top XY. Once you're able to get the top XY, then it is mentioned that width and the height. So again, it is given in the ratio format, right? So what you need to do, you need to get the width, that is 80 into 0.29. So you're going to get that value. So that will be the width. Okay, that will be the width. This is the XY. Okay, this is the XY, and this will be the width. And the height is given as 0.36. 0.36 means 60 is the height, 60 into 0.36. So you need to come that much position down. Then you are able to create the bounding box. Are you getting my point? Are you able to get my point? It is expressed as ratios. In custom vision portal, it is expressed as ratios with respect to the width and height of the image. Okay, these are expressed as the ratios with respect to the width and height of this image. So here left is given here top. This is the XY coordinates and this is the width and height. So the portal, okay, so this is the labeling format used here. And along with that, the portal, from the portal, you are able to train our own object detection models by simply dragging this box over the images. It's super simple. And along with that, once you are able to train with a limited number of images, and when you give new images for the training, it will be automatically tagged. Okay, it will be automatically tagged using the smart labeling tool. It will be automatically tagged using this smart labeling tool. That means we don't need to tag anything. So based upon the previous knowledge itself, the system is able to say that it's an apple and the location is here from an image itself. So that's the beauty that we are going to see in this video. So let me directly go and parallelly you can do that. Okay, parallelly you can do that. So let me close this one. Go and create a resource. So what is the name of the resource that I'm going to create? Or do you remember that? Which is that resource? Which is that resource?
Custom vision service.
Custom vision service. So let me go with the custom vision and check for that. Yeah, custom vision is there. Go and create that one. Okay, you can directly log into your portal and here you can see the options. Create both, prediction or training. I'm going to select both. That means I need to have this custom vision training for the training purpose and I need to have the custom vision prediction for the prediction purpose. So I am selecting this both. Subscription Azure Pass. Then resource group, I'm going to select AI102. Region, I'm using the East US region. So let me give a new name, custom mission. So let me give CUV. Okay, CUV, custom mission, CUV demo 001. Then training pricing tier. So that name is not okay. That name is available. So with the training pricing tariff, if you're opting for free version, then 2 projects can be created. So let me go and create this one. And talking about the prediction resource, let me select this free version too. So it will not be charged for me. Then after that, go and click this review plus create. You can do that parallelly. And after that, you can go and create this. You can go and create this. So it is taking time for the deployment. Deployment is in progress. We can wait for that. So now it's completed. Now we can directly go to the resource group. And you can see that CUV demo 001. This is the prediction. This is the training resource. And this is the prediction resource. Both of them belongs to the custom vision, right? So now it's good to use. Then what is the next procedure? So we are actually in the classify image, this portal. So let me share that link with you. And along with that, what is the next step? We have done all those things. Okay, we have done all those things. Next, we need to go to this customvision.ai. Okay, this is the portal that I'm talking of. Vision.ai. So let me directly go to the customvision.ai. So this is the portal. Okay, this is the portal that I'm going to use. Visual Intelligence main DC. So go and sign in with the same credentials that you are using for the Azure. So let me go and select the sign in. I'm going to select this Gmail account. Again, I'm selecting this credentials. Now you landed into this page. Now you landed into this page. So now projects is there. So this is asking about creating projects, right? So let me create a new project. So go and click this new project. Here it is asking for a project name. So let me give a new name, like suppose I need to detect fruits, apple, orange, and banana. Okay, I need to classify these fruits, apple, banana, and orange. So let me give a new name, like say, let me give like this fruit classification, fruit classification. Us. Or let me give fruit itself. Okay, let me give fruit itself. Then a classification project, Then it is asking for the project type, whether it's a classification or object detection. We can do only these two things in this custom vision portal. Remember that we can only do this classification and object detection in this custom vision. I'm going with the classification. Then it is asking for the classification type, whether it's a multi-label or multi-class. We are going with the multi-class. That means for an image, only one tag is there. For an image, only one tag is there. So I'm going with the multi-class. Then it is asking for the domains. Domains means we can train images belongs to different categories, right? When it comes to the case of apple, orange, it belongs to food category. So we can select this food category. If you're actually training some buildings, images of the buildings, you can go with the landmarks. if you're going to train your images with the items that you are going to purchase from the shops, then you can go with the retail. If you're going to train these models for using in mobile phones or in edge devices like Raspberry Pi or in NVIDIA Jetson Nano Kit or say in OpenCV AI Depth Kit, if you're going to deploy these models on these edge devices, then you need to use the compact version. Compact version is basically used for working with edge devices or mobile devices. Then if you don't know, okay, that means if you're training with the say some other objects that does not belongs to this category, then you can go with the general. Then you can go with the general option. So there are different ways in which we can do. So inside this general, you will be having specific category. So general A1, general A2, general A1 gives this is another model optimized for better accuracy. Okay, general A1 is a domain that is optimized for better accuracy, but it gives you with the similar inference time of this general category. When it comes to the case of general A2, the advantage is that the inference time is much higher than general A1 and the general domain. Along with that, you can train with small number of images. But one thing is that minimum there should be some 30 images for each of these categories. If you're training orange, then there should be some 30 images for training that orange. That's a minimum requirement. Okay. So I'm going with this general A2, general A1. You can see all those things. But in my case, it's fruits, right? So you can opt for the fruit. You can opt for the fruit. After that, you can go and create this project. So you are able to see all those things here. Okay, you are able to see all those things here. Then here at this, okay, at the top, you can see this add images. You can see this train button. You can see the performance button here. You can see the predictions here. Okay, so train images. First of all, you need to add your images. So from where you can add your images, that's the first thing. So go to the downloaded AI 102 engineer page. And inside this image classification, that is the 17th folder. Okay, that is the 17th folder. Inside that, go and select this training images. Inside, you can see some Apple images. So how many Apple images are there? 15 Apple images are there. That's good. Banana, how many images are there? 10 images of banana. Then how many images of orange? 10 images of orange. We have this training data, right? So let me close this one. Go and take this portal, and here go and select these training images and select this add images. Look at the format supported. Say .jpeg, .png, .bmp format, and up to 6 MB per image. 6 MB per image. That's the maximum size that you can give for the training, 6 MB. And if you're going with the testing time, the maximum size is 4 MB. 4 MB. Okay. So let me go and select these add images. Let me go to this AI 102 AI Astro, select the image classification, go to the training images. Let me select all the Apple images and click this open button. So I'm going to upload all the images. And what's the tag? It's Apple, right? It's Apple. So let me upload all the 15 images.
One question, Nithin sir.
Right.
So can we also upload in terms of folder rather than giving a tag here for the images?
So basically, we are actually uploading all those as images. In every case, we are uploading those as images rather than specifying the folder. If you need to work with that, you can go with the SDK. Okay, if you need to work with those folders, you can work with the SDK. That is the software development kit. With that, you can do that. But here, you need to actually upload all the images like this. Is that
Right.
clear?
Yep.
Okay.
Thanks.
So we have tagged all these images, right, by specifying the Apple. So at the left side, you can see that here you can see tags, tagged and untagged. Here under this tag, you can see that Apple, 15 images of apples are tagged. Inside the untagged category, can you see any images? No, because all the images are tagged, right? So let me add some more images. So again, go and click this add images. go and select orange. Okay, let me come back. Go and select this orange. Let me select all the images here and click this open button. And here you need to specify the tag. Consider that I am not providing any tag here. Okay, I'm not going to provide any tag here. Just upload these 15 images. So after uploading these 15 images, where it comes? That's the question. So 15 images uploaded, but it is available inside this untagged category because the system does not know what exactly these images are. Okay, the system does not know what exactly these images are. In the tag category, we are having these Apple images, and in the untagged category, we are having these orange images, but we need to tag that. How we can tag that? Simple way, go and select this button, select all, then click this tag image button and just tag that like orange, like orange. So save and close. What happened? All becomes tagged, all becomes tagged. Now each of this image belongs to this orange and each of these images belongs to Apple. Now in the untagged category, we don't have any images. Likewise, again, we are going to add the banana images. So let me add all the banana images and tag it as banana. So banana, right? So let me upload these files. Let me upload these files. So what happened? It is taking time. Oh. So I have uploaded all those things. Now we are good to go, right? You can see banana, you can see apples. If you need to see orange, you can do that. So you have provided all the training images. Can you say which is the next step? Which is the next step? We are provided with all the images. Which is the next step? Can anyone say?
Train the model.
Of course, that's the right thing. If you have the data with you, what you can do? You can train your model, right? So go and click this train button. Here, you will be having the option for quick training or advanced training. Quick training means you can quickly train your model. And if you're going for advanced training, you can train that for a longer period of time. If you're training that for a longer period of time, then the accuracy will be too higher. Okay, so two options are there, training types. You can see that use advanced training for improved performance, especially on challenging and fine-grained data set. Fine-grained data set means these are simple images, like sometimes the images contains banana, sometimes the image contains orange. We can actually detect this. So think of a cancer detection system. So in order to detect that cancer, all the images look similar, but we need to have a fine-grained, there the challenge is that we need to clearly focus on each of these images. So there are some data set where we need to concentrate more on that. Okay, so other time you can go for the advanced type. So basically quick training, I am opting for the quick training. And finally, I'm going to train my model. So now you can see that iteration 1 is actually running. That is the first iteration. So I am running my model for the first time. So it is going to take time. You can parallelly do that. Okay, you can parallelly do that. You can parallelly do that.
So,
Yes.
one question, like when we train the model or before training, we label the images, right? We use tools like label img. So here there is no such tool, and some of the models take the label information as .txt format or .xml.
Okay, I got that. I got that. I will explain that. I will explain that. So basically, Smart Label is one of the software for drawing the bounding boxes, right? So that comes under the object detection part. Is that right? So Smart Labeler is a tool for object detection. That means we are going to create our data set using the Smart Labeler tool for this object detection. Similar way, in this portal, we will be having the option, but it's for this project is for image classification. We don't need to deal with the bounding boxes. So when it comes to the case of object detection, I will show you how you can use the similar type of approach in this portal. Like the Smart Labeler tool itself, we'll be having separate tools in this customization portal. Are you getting my point? Is that clear? So I'm not getting any reply. So are you able to understand? Similar to the smart labeler software, we'll be having the software inside this custom vision portal itself for the
Yes.
object detection. And one more question. And you talked about the text.txt files, right? I told you that normally in that text files, when we are working with this TensorFlow or when we are working with the PyTorch, for the object detection, I'm talking about the object detection. Okay, now I'm talking about the object detection. I need to clarify those doubts. For each of this image, for example, for Apple, we are going to provide with the X and Y. Okay, you're going to provide the X and Y, and along with you need to specify the width and height. So basically, in those cases, what happen is that if you're going to use the text format, it is giving directly these values 30, 40. Okay, then comma, say the width like 200 and 300. It may like this. So, but when we are training with the custom vision portal, we need to convert this into the specific ranges. Like it needs to be in this format itself. It needs to be in this format itself. Are you getting my point? So we need to take the ratios of that. We need to take the ratios of that and we need to convert all these points according to that. Otherwise, we are not able to use that in the custom vision portal. If you're using YOLO, the things are different there. If you're using SSD, the things are different there. So based upon the object detection algorithms, the format in which we are supplying is different. That we need to take care of. Is that clear?
Yes, sir. So the smart labeler that you mentioned, it's not open source, right?
Basically, I will show you smart label. I think that a smart label can be downloaded. It's not open. We can download that. I have used that smart labeler. I have used that smart labeler. Or you can, what you can do that is OpenCV, go to the OpenCV portal, and here there also sometimes you are able to let me check that. Annotation tool. There's a free desktop tool for super annotate. This is another type of software with which you can annotate your things. But with this label image, I forget about so many tools I have used that label image. So you can use this label image. Are you getting my point? This is an open source software.
Yes, sir.
This is the software that I have used earlier, because we can directly install that, take the image and select the bounding boxes. Okay, so you can select the bounding boxes and you can tag that. So it's so simple. This is open source. We can do that. Or otherwise, you can directly go and use that super annotate. So there are different softwares with which we can actually work. Okay. So let me check my portal. Okay, now I'm able to train my model and I'm getting the precision. Okay, I'm getting the recall. I'm able to get the average precision. So these are the metrics in order to know the accuracy of our model. Okay, precision, recall, and average precision. So now we are able to train our models. Okay, now we are able to train our models, and these are the values for the precision and recall. 100%, because it's a clear data set, right? It's a clear data set. It's not a complicated one. That's why you're going to get this 100%. If you're sending some complicated data set, then the things will be different. Okay, so you have trained your model. After that, you can test your model. How? At the top, you can see this quick test button. Okay, at the top, you can test this. See this quick test button. Go to the quick test. Here, you can actually browse local files. You can give some new images there, right? So let me give some test images. Let me give this image. Are you able to see this prediction? Are you able to see this prediction? Yes or no?
Yes.
With 98.1% of probability, the image, its system is saying that it's an apple. With 1.8, it is saying that it's an orange. This is called as testing. This is called as testing. Okay, now we are done up to this point, right? Now we are done up to this point. Then what all are the things that I am going to focus? Okay, then go to the. Okay, so let me show you publish and before publish. Before publishing. So the next thing, what we need to do, we can go to the Visual Studio portal. Okay, we can go to the Visual Studio portal and go here. Click this image classification. Inside this Python, okay, in the 17th folder, image classification, and inside the Python, you will be having test classifier and the train classifier. You can go with the train classifier, and here you will be having some more images. So how many images? 2 images of apple, then 2 images of banana, right? Then 2 images of orange, 2 more images. Okay, altogether how many images are there in the portal? Can you say that? Altogether how many images are there in the portal? 15 images for apple, 15 images for banana, and orange, 15 images of orange. If you're adding 2 more images, then 17 images of apple, 17 images of banana, and 17 images of orange, right? So we need to do that. So how we can do that? That's the question. Then go to the I'm closing this one. This is the more images. And inside the train classifier, I am seeing these things. Training endpoints, training key, project ID. So these are the information that I need to have. Okay, these are the information that I need to have. So here, so one more thing, you can directly go here. You can go through this. Okay, so I have mentioned all those things. I have mentioned all those things here, right? Up to this point, we have completed. And next thing is that go to the settings. At the top right, you can go to the settings. And from the settings, you can see a project ID in the left side. Copy this project ID and paste that here. Okay, copy that project ID and paste that here. Then they are asking about the training key. Look at this training key. They are not asking about the prediction key. They are asking about the training key. So from where you can get that? So at the right side, you can see that CUV demo 001. This is the same thing that you are also getting from the Azure portal. So let me copy this key. This is the primary key. Copy this key here. And along with that, I need to copy this endpoint information. Copy this endpoint information. So let me do that. And let me save this. So I have provided the training endpoint, training key, and the project ID. That's good. Let's go to the training classifier.py. Okay, so let's go to the training classifier.py. Here we are going to, so in order to run this, the next thing that we need to use is, in order to use this SDK, you need to install this software, pip install Azure Cognitive Service. So let me copy this and paste that in the chat box. So you need to install that SDK. Otherwise, you're not able to run that. Okay, so go to the train classifier, right click, open that in integrator terminal, and you need to actually copy that. Pip install, it is already there. Requirement already satisfied, right? So now I have installed those. I'm going to import all the necessary modules for that. Then the same thing, we are going to load all the information from the environment file. We are going to load the training endpoint. We are going to load the training key. We are going to load the project ID. So all these informations are specified in the environment file itself. Okay, So we are able to done up to that point. After that, what we are going to do? We are going to create the credential object by passing the training key. So training endpoint and the credentials are given for creating this training client object. Okay, then with this project ID that we mentioned in the environment file, with this project ID, we are going to get that custom vision project. Which project? This project. Which project? This project. Okay, we are going to access that project from the SDK. So once we are able to do that, we can call this function upload image, upload images. So here I am passing one name, more training images. So when we look at this, you can see that this is the name of the folder. Go to the right side. You can see this more image training images. This is the name of that folder, right? So we are going to add 6 more images. 2 images of apple, 2 images of orange, and 2 images of banana, right? So we are going to call this function upload images. And what all are the tags that we used in this custom vision portal? What all are the tags? We know that in this custom vision portal. So let me go back to my project. So come inside this project. What all are the tags? I know that apple, banana, and orange. These all are the tags that I have created here. I need to get all those tags. Okay, I need to get all those tags here by running this line of code. And inside this tag, I need to extract each of these tags. What all are these tags? Banana, orange, apple, right? So I'm going to print those tags here. Then os.path.join folder, tag.name. What is the meaning of this? So here, folder name is this one, more images, training images. Inside that, I'm going to append this tag.name. Tag.name means it can be apple, it can be banana, it can be orange. So I'm going inside this folder and I'm going to extract each of these images from this particular folder. And I'm going to add that to the custom vision portal. So this is the thing happening here. Okay, this is the thing happening here. So after running this function, we are able to load 2 more images to this category, 2 more images to banana, and 2 more images to orange. Is that clear?
Nitin sir, we are just going to use the existing model. We are just going to predict now.
Yeah, exactly. So I told you that in the classification. So look at this, create a project or you can retrieve an existing one. In this case, we are actually using this.
Got it. And that's,
here,
I think, we used the prediction endpoints.
So basically, here we are going to train from the here we are going to train our new model, that is the iteration 2 from this. Are you getting my point? Here we are going to train our new model with those 2 images. Earlier we have 15 images for apple, 15 images for orange, and 15 images for banana, right? Along with that, we are adding 2 more images to apple, 2 more images to banana, and 2 more images to orange. After that, we are again retraining our model.
Okay, got it. Thanks.
Okay, so we are going to retrieve the class tags and we are going to upload the tagged images. This is the thing we are doing. Up to this point, we have mentioned. And finally, we are going to train your model. For training your model, what you can do? The same thing. You can get the custom vision project.id that we have given there. And during the iteration, we are checking that whether this iteration status is completed or not. If it is not completed, that means it is in the training stage. It is in the training stage. When this iteration.status becomes completed, that means the model has been trained. Okay, the model has been trained. That's the idea that we are going to build here. So what I am going to do is that I'm going to save this model. Okay, I'm going to save this program and run this. So in order to run this, first of all, I need to come inside this train classifier. Okay, now I am inside this train classifier and let me run that code, Python train -classifier .py. So let me hit enter. You can see that uploading images, banana, apple, orange. Okay, that sounds good, right? So training, again, it's showing training after 5 seconds. So now it is training. without clicking that train button in the custom vision portal. But if you're actually refreshing the things, so let me refresh the things. So can you see 17, 17, 17 here? Are you able to see this one 17, 17, 17?
Yes.
So it get uploaded from the SDK. It gets uploaded from this SDK, but still it is training. Okay, still it is training. So let me check that training. It will take time. It will take time. So after that, you're going to get the completed message. If you're going to get the completed message, that means it's trained. It trained. So these are the strategies with which we can actually work. If you're interested in SDK, you can go with that. If you're interested in portal, you can go with that. There are multiple ways in which we can work.
But if the image is having some text, we have to extract that text from the image and try to make that as a text for text
Okay, I
analytics.
got
Is
that.
that
I got
possible?
that.
Yeah.
Yeah, is that that is possible. And in order to deal that with, we are having a separate module for that. Okay, so that is the next, that is the 10th, that is the 11th module. Okay, that is the
Okay.
11th module. 11th
Sure.
module is all about how to extract text from the images, how to extract forms, receipts. From the forms and receipts, we are able to extract the organization details. Then we are able to extract the items that we have purchased. Okay, all those things are given inside this. I will show you. I will show you. So inside this AI Engineer Master itself, you can see that custom forms OCR, 20,
Okay.
20
Got
exercises
it.
OCR.
Yeah,
So
got it. Thank you. Thank you.
we are going to learn all those things here. So that's this course. So let me directly check my Visual Studio portal. It's still training, right? So we can wait for that. Parallel, you can do that. Parallel, you can do that. Here, you don't need to copy anything apart from this that training ID, then the endpoint, and also the project ID. So let's wait for that training. And when it comes to the case of test classifier.py, okay, here you can see that you will be having inside this Python folder, you will be having the test classifier and the train classifier. Now we are actually working with the train classifier. Okay, so we can wait for that otherwise. So mm, training. Next thing is highly important that we need to take care of. Otherwise, we are going to get wrong result. I hope that all of you are working from your system. Rather than using the virtual machine, it will be more comfortable to work with your system. So try to use that. If you're not able to run in your systems, then go and use that virtual machine. So the main advantage of using that virtual machine is that you don't need to install any softwares. All the softwares are updated there. It is taking huge time, right? So So we can wait for that. So before that, I need to explain the text code also. The same idea is there. Here you're going to provide with the prediction endpoint and the prediction key. Along with that, you're going to supply the project ID. That is the same ID that we have used earlier. But along with that, you need to provide the model name also. That's a new thing that we need to do in this. Okay, model name. So I will tell you what exactly that model name is. What's the status? Now it's completed, right? So you are able to get this message, completed, model, trained. So let me go back to the portal. So let me go back to the portal and let me check the performance. This is the iteration 2. You can see this iteration 1, iteration 2. This is the second training, right? So we are retraining our model with additional images. So you're going to get all those information here. Can you see this publish button at the top left? So in order to use this model from your okay, one more thing is that sometimes you may be asked with some other questions. Can you see this export button? Are you able to see this export button? Yes or no? It's actually disabled there. Can I get the confirmation?
Yes. See that.
So this will be enabled only when you are training your models for compact domain. That means if you're training for the mobile devices, if you're training your models for the mobile devices, then you are able to export this model. Otherwise, you are not able to export this model. So this will be enabled only when you're going with the compact domain. So at the left side, you can see this publish button. Go and click this publish. Okay, go and click this publish. Here you can give a new name. Say like I'm going to give like this fruit. Say fruit classifier. Fruit. This is our model name. Fruit classifier. And please choose the prediction resource. So I need to choose my prediction resource. This is the custom vision prediction resource, and go and click this publish button. Go and click this publish button. So now it becomes, you can see this unpublished. That means it's published. If you need to unpublish, go and click this button. So that's the idea. Then what is the name of our model? It's a fruit classifier, right? So let me copy that thing here. Fruit classifier is name of that model. What about the settings? What about the settings? So what you can do is that, please carefully listen to this. You can directly go and click the icon that is available at the top left. You can see this eye symbol, right? So go and click this eye symbol. After that, come to the settings that is available at the top right. Okay, first of all, you need to select this eye symbol that is at the top left. And after that, once you reach this page, you can go to the settings. So go to the settings. Here you can see prediction resource, right? Here you can see the prediction resource, and this is the training resource. You need to use this prediction resource. Go and select this prediction resource. You can see the key. So copy this key. Copy this key. Then copy the endpoint. Okay, copy the endpoint. After that, you need to get the name of your project, right? So what is the name of, you need to get the name of your project ID. So from where you can get, go to the settings here. Here, this is the same project ID that you're going to use. So let me copy that information too. And in the Visual Studio, you can close all the train classifier. Now you're going to test that. In the environment file, let me copy all those things together there. So that thereby we cannot switch back to each of the cases. Let me put the name here. Cut. Let me replace my name like fruit classifier. Then this is the prediction resource, right? So let me cut that and paste that here. This is the prediction key. This is the prediction endpoint, right? So this is the prediction endpoint. And this is the project ID. This is the project ID. So let me cut that and paste that project ID here. So we have done up to this point. Okay, we have done up to this point, and go and save this. Go and save this. Then go to the test classifier.py. And here you're going to import all the necessary libraries for that. We are going to load the prediction endpoint, prediction key, project ID, model name. This is same as that we done earlier. Then we are going to authenticate the client for the training API. Okay, so we are actually using the, we are going to actually test that. Okay, we are going to actually test that.
Nithin, this is Gopi. I had a glitch in the connection for a couple of minutes. Can you please?
Okay.
Because
Explain those things,
you
right?
said that it is very important and I got disconnected.
Okay.
Okay, can
So
you please? You
from
are telling
where
about
you are
some
able to,
icon,
yeah,
icon.
sure.
Yes, please.
I will tell you that. So let me explain those things again. So now let me load that again. Why I'm not able to see this? So now I'm having the net connection. Okay. So okay. Okay, so now what happened is that you need to actually access the training prediction key resource and also the application ID or the project ID. From where you are going to get that? Are you able to see the settings at the top?
Yes, I can see the settings.
So you can copy this project ID. Okay, you can copy this project ID from there. That's the first thing. And after that, at the top left, you can see this eye icon. Can you see this eye icon?
Yes.
You need to actually select this eye icon. That's the important thing. Then come to the top right, and here you can see the settings gear. Top right. Can you see this settings gear?
Yes.
Go and select that settings gear. Here you are able to see two resources. One is the prediction resource and the training resource.
Yes.
You need to select this prediction resource.
Okay, yeah.
Then from here, you need to copy this endpoint and the key. Otherwise, what happens is that if you're not doing that, then you're going to copy the training resource data.
Okay.
If you are not using this pattern, you're going to copy the key and endpoint of the training resource. For that, you will be going to get error. That's the thing.
Okay.
So once you are able to access all those things, you can copy all those things here. And fruit classifier is the name of your project. That means let me tell you once again. So go to the custom vision portal, and here in the main page, you can go with the performance. Sometimes it is taking too much time, so we can wait for that. While publishing, we have given a name, right? While publishing, we have given a name. So that name is this one, fruit classifier. So you need to use this exact name, what you have given here. Okay, you need to use the exact name that you have given here. So paste all those information in the environment file that is within this test classifier. Okay, that is within this test classifier. After that, you can go and open this test classifier.py. All the things are similar. You need to load all this information like the prediction endpoint, prediction key, project ID, and the model name that is given inside this environment file. Then same thing, you're authenticating the prediction client. And you need to supply images for the testing. So where these images are? So inside this test classifier, you can see this test images folder, right? You can see this test images folder. Go and expand that. So here you can see one image of apple, one image of banana, and another image of orange. So 3 images you are going to submit to this model. So this is within this test images, right? So let me go and close all those things. Okay, let me go with the test classifier.py. And here, what we are saying, from the test images directory, you need to read each of these images and you need to send that image to the model. So classify image is the function for that. Here you are going to specify the project ID, model name, and your image. It's within this for loop, right? So firstly, it is going to send an apple. Secondly, it is going to send an orange image. And finally, it is going to send a banana image. Okay, for these 3 images. And for these images, you're going to get the results in this result variable. You're going to get the results in the result variable. And you're checking that prediction. You're checking that whether the prediction dot probability is greater than 0.5. That means if the system is saying that the probability is above 50%, then you're confident about that. This image belongs to that particular tag. Okay, if the system is saying that for apple, banana, it's below 50%, then it is not going to show that. So you need to specify a threshold for that. Here, by default, it is given as 50%. If you need to set it as 70, you can do that. 0.7, you can set it. That's all depends on your logic. Okay, you can set a probability there. And based upon that probability, we are going to get the result. So in order to run this again, the thing is that we need to install this pip install Azure Cognitive Vision service. So what you can do, you can select this test classifier, open that in integrator terminal, and okay, and you can actually copy that pip install. It's already there in my system, so I'm not going to reinstall that again. Inside this test classifier, which is the file that I need to run, this one, Python test classifier.py. So let me type Python test classifier.py. So it is taking time. So let's wait for that. Let's wait for that. Image one dot test dot. Oh, it is giving apple, banana, orange. Are you able to see the result? Are you able to see the results?
Yeah.
You are able to see the results. And the question is that, can we see these results from the custom vision portal? So this is my custom vision portal, right? So go to the predictions tab that is located at the top. Okay, before this train button. So go and click these predictions. Go and click these predictions. So it is loading. It is loading. Wait for that. So what all images that you have supplied to this model will be displayed here. You can see this. So you have given 3 images. The 3 images can be seen from this customization portal. So this is all about the image classification. I hope that it's clear to you. Is that okay? Is that okay? You can do the same thing. I will give you, do you need to have the time for doing this? 10 minutes? Yes or no? Otherwise, we can go with the object. So one thing is that, so let me take that object detection also. So during the training, it will take time. It will take time. So normally what we are doing is that it's a similar thing. It's the similar thing. Object detection, it's a similar thing. So let me go to the custom vision portal. Let me go to the custom vision portal, and now I am going to delete this project. So before deleting, you need to take care of this performance, and in this performance you need to unpublish this. Okay, you need to unpublish this. So go and unpublish this. After unpublishing, you can go to the tab and you can delete this. You can delete this. So next is all about object detection. You can use the same portal. You can use the same portal. Here, please look at this. Please look at this. Earlier, one participant asked me regarding how to label the images in this custom vision portal. Now I am going to say that. So go and click new project. So let me type fruit detector, fruit detector.
Take some animal kind of thing rather than on the same data set.
So actually, I don't have any data. You can do that. You can do that. If you're selecting that, then go for general A2 domain. Are you getting my point? I don't have that data set with me. I don't have that data set with me. And if you have that data set, you can do that. You can do that, provided in this domain, you need to select this general A2. Are you getting my point?
Okay.
It's not a food. It's not a food, or it's not a landmark, or it's not a retail. That's why I'm saying that go for general A2 domain. Then if you need to give description, you can do that. Okay, if you need to give some description, you can do that. I'm not going to give that. So resource, this is the F0 resource. You can test with whatever data set that you have. Okay, so that's not an issue. But here the project type needs to be object detection. Okay, object detection. Then I'm going with the general A1. So here we don't have the food domain, right? In this object detection. So go for the general A1 domain. This is the best matching domain according to my data set. So let me go and create this data set. Oh, not the data set, this project. We are up to this point. Okay, we are up to this point. Then I need to show you something inside this object detection. That is the 18th folder. You can see some training images. What is the difference between the earlier images and these images? Multiple.
These are multiple labels.
Right. So in this single image itself, we will be having multiple fruits. So we need to detect this location. So how many fruits are there? 10 fruits are there, right? 10 images. Oh, not 10 fruits, 10 images are there. So let me go to the portal. Go and select these add images. Go to this AI102 18th object detection. Go to the training images and let me add all these images. Let me add all these images. Go and upload the 10 images. We are done with this, right? We are done with this. So let me click this, done. Then next is the important thing that we need to understand. You can select one image. Are you able to see this? You can drag this object and you can type Apple here. So it is getting the tag Apple. Then automatically when we hover the mouse over this orange, it will be automatically given this bounding box. If you need to resize, you can do that. It's an orange. Then banana, right? So banana, oh, this is banana. So I need to rename, this is banana, right? So I am going to type banana. So I labeled all the objects in the first image and click this next button. Go and click this next button. So I click two buttons. Okay. So let me go to the previous. Okay, it's labeled. Then what you can do? You can select orange here. You can select banana here. Okay, now it's labeled. Go to the next one. This is apple, right? Apple. This is orange. If you need to rearrange, you can do that. This is banana. Okay, that's good. So instead of smart labeler, we can use this approach. It's orange. It's again orange. It's apple. Then it's banana. Right, go and select the next button.
This is by Microsoft only, or this is some third party?
It's not third party, it's from Microsoft. It's a inbuilt software inside this custom vision itself. Apple, then orange, then pick banana here. Otherwise, we need to manually do all those things. That's a little bit difficult thing when it comes to the case of object detection. If you're working from scratch. When I was doing research sabbatical in Bennett University, I worked a lot for this object detection. Then banana. Okay, how many images more? So with this 10 images itself, we are in trouble, right? So it is taking time. It is not detecting, right? Orange, apple, then orange. Okay, that's good. So I think one more. This is the last image. Orange, apple. If you need to resize that bounding box, it's okay. You can do like this. Okay, Oh, then orange. This is the last image. Okay, that's good. So at the left side, you can see that 9 apples are there in the entire image. 7 bananas are there in this entire image. 10 oranges are there. Is that clear up to this point? Yes or no?
Yeah.
What is the next step? Can you say that? What is the next step?
After labeling, let us train it.
Sure, you can actually go and click this train and you can opt for this quick train. Oh, your project can't be trained just yet. Make sure you have at least 15 images for every tag. So you don't have that much of images, right? So we have missed something. Okay, so okay, we have provided. I need to check that, and we can submit more images from the SDK itself. Okay, we can do that. We can do that. So let me copy this project ID. Okay, let me copy this project ID. Then go and give the endpoints, copy the endpoints. And here you can see the training key, right? Go and copy this training key. So if you're done with that, let me show you one thing. Go and close all those things, all those code files. So come to the 18th folder, that is the object detection. And inside this Python folder, you can see this train detector. Okay. So please focus on this code. Here we are not going to train our model. Please carefully listen to this. With this code, we are not going to train our model. We are going to upload more images. That's the only thing that we are going to do with this code. We are going to click that train button again. So let's go to the images. You can see some images here. Okay, you can see some images here. Can you see this? Some images are there, right? So along with that, you'll be having some information regarding each of these images. For the first image, that is image 11.jpg, the tag is orange. These are the left, top, width, and height. This is the okay, in the image 11.jpg, you will be having 2 objects. That is this information. In the image 12.jpg, you will be having 3 objects. So these are the information and the location of that 3 objects. In image 13.jpg, 2 objects are there, orange and banana, and these are the locations of that. So all these informations are there inside this JSON file. Okay, now you will be having these images. These are the images, right? These are the images, and you will be having this labeled information that includes the location and the corresponding tags. Then what you can do? Go to the environment file. What is your training endpoint? Training endpoint is this one, right? So go and copy this training endpoint. Then go and copy this. This is the key, right? So go and copy this key. And you can use this project ID. Copy this project ID. So once you're done with that, we can actually go to the train detector.py. So we are importing all the necessary libraries. All those things are exactly same as in our earlier example. Okay, up to this point. Okay, up to this point. Earlier, we will be having that upload images. And if you are remembering about that, what is the next function after this upload images in our earlier case? After calling this function, which is the next function that we called earlier, train images, but it is not there. That means we are not going to train from this script. We are only going to upload images from that script. So basically, what we are going to give, we are going to give the images. This is the folder name. Okay, this is the folder name. You can see that images is the folder name, right? So we are passing this folder name to this function. First of all, we are going to extract the tags from the existing project. Which is that existing project? We already created one project here, right? So this is the fruit detector, right? This is the fruit detector. We are going to extract that information from the existing project. That is a fruit detector. Then we need to create the files. Files means for each of this object, for each of these images, we need to specify that what all are the objects present in that image and what all are the location information of each of this object. So you need to create a list for that. So you are going to create an empty list that is tagged images with region. Then you're going to read that JSON file. Okay, you're going to read that JSON file. Then this is the code for, okay, this is the code for extracting the details from this JSON script. Okay, this is the code for extracting the details from this JSON script, each and every value from this. Okay, each and every value from this. This script is going to extract each and every value from this. And finally, it is going to create the list of images with the tag region. Okay, after running this code, what happened is that this list contains all the images associated with the tag and the location information. So you can see that for JSON.load JSON file. This is for loading the JSON file. After that, you need to look into this tagged images files. Tagged images files. What do you mean by that? Tagged images files. So this is the thing. Tagged images files. You need to go through these files and you need to extract this file name. And from this file name, you need to go and look these tags. What are the tags? There are 3 tags for this image, right? So we are going to extract each of these tags. And finally, you're going to append this information inside this tagged images with region. Okay, you can go through this. You can go through this. So these are simple Python codes. These are simple Python codes. I hope that you are able to do this because you are actually learning AI, right? So these are the things that we need to have in order to create this list, tagged images with the region list. Once you are able to do that, this is the important step. After that, you are going to create image from files. That means you're going to call this function. When you're calling this function, what happened is that you're going to upload the list of images. That means inside these images, you will be having some images, and along with that, you will be having some tags. Okay, you're going to upload all the images as batch, and we are checking that if that image batch is uploaded in a successful way or not. If it is not successful, then you are going to get this message upload failed. And if it is if it is a success one, then you are going to get this images uploaded statement here. So let me save this file and run this. So in order to run this, you can type Python. So actually I am within this test class file, right? So I need to go and select this train detector. So now I am inside this train detector, and I need to actually type Python train detector .py. Uploading images. So we can wait for that. We can wait for that. So it will take time. It will take time. So let's wait for this uploading images. Both the things are simple, right? Both the techniques are similar. That is, image classification and object detection is similar. So here you can see that images uploaded. Images uploaded. So let's go back to this project. So let's go back to this project. And now we will be having 18 images of apple, 20 images of banana, and 20 images of orange, right? So we are able to get all those things. And finally, you can train your model. Now it's available, right? Go and select this quick training and select this train button. So it will take some time for the training. So let's check waits for that. Apparently you can do that. Is that clear? Is that clear? Can I get the confirmation? Is that clear? Why no one is responding? Is that clear?
Yes, sir.
Okay. Now training is actually undergoing. You can similarly train your model. You can upload the images from the directory and also try to run that code so that sufficient images will be there for training this model. This is the object detection model. So once we are able to train, then what is the next step? You can actually go to this test detector. Okay, you can actually go to the test detector. So let me close this code. Then close this environment file. You can go to this test detector, and here you can see this prediction endpoint, the prediction key, the same way in which we have done for this image classification. You need to obtain all these keys, and this is the image that you are going to test. Okay, this is the image that you are going to test, and the name of that image is produce.jpg, right? Produce.jpg, and this is the test detector.py. So here we are going to get all the prediction keys, endpoints, project ID, and the model name. You are going to authenticate the client, and finally you are going to give this produce.jpg file, and you're going to get this height, width, and the channel information. You're going to convert that into array, and you're going to call this prediction client.detect image. So detect image is the function that you're going to call, and inside that you are going to pass this project ID, model name, and the image data, which is this image data produce.jpg. So this is the image data that we are going to give, and module name, project ID. And once you get these results, this results contains the information regarding the bounding box, right? So this result contains the information regarding this bounding box, and then with the magenta color, as we done earlier, with the magenta color, we are going to extract the left top, height, and the width, and we are going to draw that line on that particular image using this magenta color, and finally you're going to save that image in output.jpg. So this is the thing that we are actually doing in this test detector.py. So again, training is going on. Okay, training is going on. So here you can see that once in this prediction, results.prediction, you're going to get the prediction probability by prediction.probability into 100. If it is greater than 50%, that means if the probability is greater than 50%, then you are extracting the left coordinate, and that needs to be multiplied with the width. Top needs to be multiplied with the height. Okay, in order to get the left top, this is the top, this is the top coordinates, right? This is the top coordinates along with the height and the width. If you're not, if you are able to do that, what you're going to do, you're going to specify the coordinates. That is the left top, left width plus top. Here, what we are going to do is that we need to provide all this information. Like if you're giving the image, look at this. If you are giving this, if you need to draw something like this, then you need to specify this coordinates x and y. You need to specify this coordinate x and y. You need to specify this coordinates x and y. Also, you need to specify this coordinates x and y. Okay, then think like that. X, y, then you're given with width and height. So this will be x comma y. So what will be this coordinate? Can you say that? What will be this coordinate? In terms of x, y, w, and h.
X
X
plus
plus width plus x plus width comma y.
X plus width comma y, right? So what about this coordinate? X comma
0.
x comma. I need to get in terms of x and x,
Y.
y, w, and h.
Y plus h.
y plus h.
Y
y
plus
plus h. What is this one?
X plus w comma y plus h.
X plus w comma y plus h. So these are the coordinates. I need to specify all these coordinates. That's the idea that given here. You can see that left top, then left plus width top, then left plus width top plus height, then left comma top plus height. You are specifying all those things. That means it is revolving like this. Okay, you need to specify from here onwards, from here to this. Okay, sorry. So from here to here, you're going to specify that. You're going to draw all the lines here inside that. So let me check my. So it's still training. It is taking too much time. It is taking too much time. So you can parallelly do that. You can parallelly do that. After that, so come back at. I will give you the time for doing. So now time is 4:48. Okay, now the time is 4:48. So let me give you 10 minutes for completing this task. So come back at 16:48. That is 4:58. Hello, 16:40 or 58. It's 16:58. Okay, 16:58. Come back at 16:58. You can do all those things there. So are you there? Are you there?
Yes.
Okay. So now we can see this iteration is completed. Okay, now we are able to train our detection model. And what we can do? That's the next question. Okay, what we can do? So let me go to this AI 102 engineer and let's check if there is any image for the testing purpose. So let me go there. Let me go there. Custom training, train model, training classifier. So training images. Okay, so they have not tested that, but we can test that. We can test that. So let me select this quick test and browse a local file. So out of that, let me give one of this image. Okay, let me give one of this image and test that. This is from the same training image, and you'll be able to see that it is going to give you the right answer, right? Apple with 99.9% of probability. It's an orange with a 99.9% probability, and it's a banana with 43.1% of probability. You can see all those information at the screen. Okay. So this is all about the testing. And in order to publish this, what you can do? The same approach, go and click this publish button. Okay, go and click this publish button. You can give a name for that. So let me give some name. Detect. Okay, fruit detect. I'm going to give that name, fruit detect. Okay, fruit underscore detect. Choose the prediction resource. So let me go and click that publish. So this is the name, right? So this is the name. So let me put that name here. Go to the settings, copy the project ID, copy the project ID and paste that here. What is the next step? Go and select this icon that is located at the top left. This is the I symbol. This is the I symbol, right? So go and click that I symbol. Then go to the settings. You can see these two resources, prediction and the training resource. Go to the prediction resource, copy this key and paste that here. Along with that, copy this endpoint and paste that here. Okay, we have pasted all those things. So let me go to this test detector. Inside that, you can see this environment file. You need to paste all those things here, right? So let me copy those things and paste that here. So fruit detect is my name. So cut this and paste that here. Then this is my project ID, right? So cut this project ID and paste that here. So I have made a mistake, right? Project. Then copy this key and paste that here. Copy this endpoint and paste that here. We have done that. Detect. Okay, so let me save this file and go to the testdetector.py. And I told you that finally you're going to see one image with the name output.jpg. So let me run this code and test that. Python, what is the name? Python testdetector.py, right? So Python test py. So let me hit enter. Oh, okay, what happened? Python test detector. Okay. Now I have not chosen this one, right? Open that in integrator terminal. Test detector, Python test detector.py. hit enter. Detecting objects in produce.jpg. We can wait for that. Result saved in output.jpg. You are able to see this message. So at the left side, you can see new file. We have given this produce.jpg. Okay, we have given this produce.jpg file and we got this as the output. Okay, we got this as the output. So this is the image that we are getting, and we are able to detect each and every fruit, and we are able to of that fruit with the associated confidence score. So this is all about the object detection. Okay, this is all about the object detection. So let me come back to the slides and let me ask you some questions. This is the first question. Okay, one more thing before diving that, one more thing that I need to show you in order to answer that question. Actually, it was not there in this exercise, but I need to explain that. I need to explain that. Otherwise, you'll be confused while attending the examination. So let me add one image, this image. Okay, let me add one image and I will show you. So after adding, can you see this get suggested option at the bottom? Are you able to see this? Can I get the confirmation regarding this? Are you able to see this suggested get tags? Are you able to see this option? Are you able to see this?
Yes.
So what you need to do is that, first of all, you need to add some images. So this image is already, the one image will be added, but it is not getting there, right? So the thing is that this is not, let me add other images. Let me add other images. Go to the training images, or let me go to the image classification, training images, Apple. So let me put this one. So inside this untagged category, I'm able to see this image. Okay, I'm able to see this image. So it's not tagged. It's not tagged. And there is one option. We have already trained this model. Okay, you have trained this model. And there is an option called suggest tags that will automatically help you in tagging untagged images. Okay, suggested tags option is there that will help you in tagging untagged images. In order to do that, you can select this get suggested object, and here you can see that whether you need to tag all the untagged images, or you can specify the limits that you can give. So here I'm going to select get started. So when I select this, can you see this? It is automatically tagged here as Apple. Are you able to see this? Can I get the confirmation? Are you able to see this? It is automatically tagged. I have not given any information. So based upon the previous knowledge, based upon the trained model, it is able to tag the information for you. That is called as smart tagging. Smart tagging. We don't need to type anything there. It will be automatically tagged there. And we just need to confirm that whether this tag is right or wrong. So this is called as smart tagging. And let me move back to this. Slide and ask you the first question. You want to train a model. You want to train a model that can categorize an image as cat or dog based on its subject. What kind of custom vision project should you create? You want to train a model that can categorize the image as cat or dog based on its subject. What kind of custom vision project should you create? I'm waiting for your answers. One, two, Okay, 1, 2, 2. That will be confusing, right? Okay. 2. So look at this. Look at this. Please carefully look at the questions. Look at this. That can categorize an image as cat or dog. An image as cat or dog. An image as cat or dog. Which is the right answer? Categorize an image as cat or dog. So the right option is multi-classification. Why? Because they are saying that in that image there will be only cat or dog. Why? Because look at this sentence, categorize an image. They are saying that for that particular image, you need to label it as cat or dog. So if you need to do that, you can go with the multi-class classification. Are you getting my point? So this is the right answer. That's why I told you, you need to clearly read the question. Sometimes it will be too tricky. Which of the following kinds of Azure resource can you use to host a trained custom vision model? This is the important point here. This is the important point here. Which of the following kinds of Azure resources can you use to host a trained custom vision model? Option 1, custom vision training, computer vision, and cognitive services. 2, 1, 3, 1, 3. Okay, I'm seeing your messages. You can type 1, 3, 1, 3, 1. Okay, so let me. Okay, 1. Most of them are saying 1, and some of them are saying 2, and some of them are saying 3. Okay, so my question is that you are actually dealing with this custom vision model, right? If you're going with this custom vision model, then there is no use of this computer vision. We cannot do any training in this computer vision. So we can discard that. Other two options are custom vision training and cognitive service. What they are saying, they need to host a trained custom vision model. That means they already trained one model. Okay, they already trained one model. They need to host that. Hosting means you need to get the prediction out of that model. Okay, you need to get the prediction out of that model. If you need to get the prediction out of that model, then custom vision training cannot be used. If it is a prediction, then we can use that. But here it is mentioned as training, so we cannot use this. So in order to host a trained custom vision model, you can use this cognitive service, or you can use custom vision prediction. Custom vision prediction. So these are the two options that you can choose. Okay, you can use custom vision prediction or cognitive service. So the right answer is third one. So last question. What must you do before taking advantage of the smart labeler tool when creating? Okay, what must you do before taking advantage of the smart labeler tool when creating an object detection model? So the first option, create a JSON file containing the bounding box coordinates, tag some images with the objects of each class, and train an initial object detection model. Third option, train an image classification multi-label model. Which is the right one?
Second one, sir.
Second one. Okay, so what about others? What about others? So they are talking about object detection. Okay, they are actually talking about the object detection. Okay, here here you can see that they are actually talking about the object detection. So we can ignore the third option. Here they are talking about the image classification. So you can actually discard that. And there is nothing to do with this JSON file for the smart labeler. So we can discard this one. In order to use this smart labeler tool, what you can do? You can tag some images with the objects of each class. Then you can train your model. After the training, if you are giving some more images, then you can use the smart labeler. It will automatically tag the things for you. You can just decide whether you need to confirm that or not. Okay, so that's the thing. So the second option is the right answer for this. Okay, so you are up to this point. So this is all about this module. And now we are going to start with the next module. So basically, I'm not sure whether I'm not whether I'm able to complete that or not, but still we need to go a little bit. Otherwise, we will not be able to cover all the topics in the last day. So let me go with the theory part, and if possible, so the actually the lab part is little simple in the first case. So let me go with that, and we can check whether it will cover or not. Okay. It's super interesting topic. Again, it's a computer vision topic. So basically, in the 10th module, we are focusing on how to detect, how to analyze, and how to recognize faces. Okay, 10th module is all about talking all about these faces, how to detect those faces, how to analyze those faces, and how to recognize those faces. Okay, so basically in this module, we are going to split that into two components. In the first lesson, sorry, again, I lost my control with the pointer. Okay, so in the first lesson, you're going to learn about how to detect faces with the computer vision service. Look at this. In the first lesson, we are going to learn about how to detect the faces using the computer vision service. In the second lesson, we are going to use more specialized service called as face service. So here the competitor is this face service when compared to this computer vision service, or we are actually comparing this computer vision service with the face service for the face detection part. Okay, that's the main goal that we are focusing in this module. So let's go to the first lesson, detecting faces with the computer vision service. We already created one computer vision service, and that is available inside the Azure itself. Okay, so let me minimize this video screen. Here you can see some images. You are going to submit an image to the service. Okay, you are going to submit an image to the service. If you're using the computer vision service, this service can detect the age of this person. It can detect the gender of this person, and also it can detect the face by specifying that in a bounding box. Okay, if you're giving image to this computer vision service, what all are the things that we can extract? We can extract the age information, you can extract the gender information, and also you can get this location information of that face. If you're using face service, you're going to get the age, you're going to get the gender, you're going to get the location information, you're going to get much more facial features like the hair information, then you're going to extract the emotions of that face, you can detect the head pose, you can do the face verification, you can do the face recognition. Okay, you can do several things using this face service. But with the computer vision service, we are only able to extract age, gender, and the face locations. So that is all about the face service, computer vision service. Face detection can be done, and also limited facial feature analysis. That means age and gender. Okay, only these two things can be done using this computer vision service, face detection and limited facial features. But when it comes to the case of face service, we are able to detect the face. Along with that, we can have the comprehensive facial feature analysis. Then you can compare two faces, you can verify the faces, you can recognize the face. So all these things can be done using this face service. So when we are dealing with this face detection and facial recognition, we need to take care of the responsible AI principles. Here, data privacy and security is one of the main concerns. So we need to take care of that. We need to ensure that personally identifiable data means that is the data belonging to a specific person. Okay, is not accessed improperly. That means other people won't be able to access this data. So we need to take care of this data privacy because they have given that data with us, and we need to ensure that we are not going to share that data with others. So we need to take care of this data privacy and security. Then talking about the transparency, here the users should be informed about how their image will be used in our system. So they have the right for that. They need to know for what purpose we are using their face images, or what purpose we are using their images. So transparency needs to be there. Data privacy and security needs to be there. Fairness and inclusiveness. What do you mean by that? Look at this. Facial recognition should not be used in a manner that is prejudicial to individuals based on their appearance or to unfairly target individuals. That means this facial recognition system should not be used in another ways. For example, think like this. If someone, there are so many things for that. If you're training our images with the white people, then what happened if you're going to give another category of people? So we are actually making some comparisons there, right? So that's not a good thing. So based upon we can detect who all are white people and who all are black people or who all are other kinds of people. It's not good. It's not good. Okay, so fairness and inclusiveness needs to be there in that. Okay, so we need to take care of this responsible AI concepts. And when it comes to the case of face detection with the computer vision service, okay, we are now talking about the computer vision service. Okay, we are talking about the computer vision service. You know that analyze image function is the function used earlier. When we learned about this computer vision service, you see that we are actually using this analyze image function, and inside that you are specifying faces as a visual feature. So this is the same thing that we have learned. You need to provide the endpoint. This is the version. You're going to have this one, that is the analyze word. And inside these visual features, we are going to specify faces. Okay, inside these visual features, we are going to specify the faces. And along with that, you need to supply your image by passing the URL, or you can give the binary image data. When you are giving this to the computer vision service, okay, when you are giving this to the computer vision service, consider this image as the input data, and you're going to get all this information. Inside the faces, you're going to get one information, and you're going to get the another information. Look at this. First person, age is 32. You are able to get the gender, that is female. You're going to get the location of that particular face. And for the second person, age is 29. You are able to extract the gender of that person, and also you're going to get the location information of that face. With this computer vision service, we can do only these things, only three things. We can detect the faces, we can extract the gender, and the age. Remember these things. Highly important. Remember these things. So when it comes to the case of face service, okay, when it comes to the case of face service, what all are the features that we can extract? So look at the case of face service. If you are using this face service, we can detect the faces. Then face attribute analysis is there. Face landmark location. So what do you mean by that? What are the various face attributes? Gender, age, emotion, head pose, hair, facial hair, glasses, whether the person is wearing glass or not. It is able to detect sunglass or reading glass like that, whether makeup is there or not. Blur, exposure, noise, occlusion. Okay, these all are the face attributes that we can obtain using this face service. Okay, then talking about the facial landmark location. What do you mean by landmark? So when we are considering the important okay, so when we are considering this face, you can see that when it comes to the case of lips or when it comes to the case of mouth, it will be like this, right? So these are the important key points. Then you will be having one nose there. Okay, so we are able to get this information. And when it comes to the case of eyes, you are able to get the key points. Okay, so you are able to extract the facial landmark location, where this nose is located, where this eyes is located, mouth, all those things. Then face comparison. Face comparison means, what do you mean by face comparison? We are comparing whether these two faces are similar or not. Okay, we are able to compare whether these two faces are similar or not. Then what do you mean by facial recognition? Facial recognition means we are familiar with that, right? In our companies, when we need to take the okay, when we are coming to the company, we first of all move in front of that facial recognition system. So it is able to detect that detect our face, and it is going to mark the attendance, right? So facial recognition can be used for several purposes. And if you need to use this face service, you can have this standalone face resource, or you can go with the cognitive service resource. If you are opting for this cognitive service resource, then inside this cognitive service, you are able to use this face resource, or you can go with the face resource. There are two ways in which you can provision this. Then we are talking about the detected face identification. Detected face identification. When we are submitting an image, please listen to this. When we are submitting an image to this face service, it is going to give you an anonymous ID. Okay, it is going to give you an anonymous ID. Okay, whenever we give an image to this face service, once face is detected, it will give you with an anonymous ID. And that anonymous ID will be retained in the service for 24 hours. Okay, that anonymous ID will be retained in the service for 24 hours. So what is the use of this anonymous ID? Okay, what is the use of this anonymous ID? So we can compare whether two faces are same or not using this anonymous ID. For example, look at this image. Look at this image. When we give this image to the system, it is going to give you with this ID. When I'm going to give this image to the system, it is going to give you with two IDs. This is one anonymous ID and this is another anonymous ID. Right? Again, I am asking you, who is this person? But you don't know who is this person, right? You don't know who is this person exactly. Who is this person? But still, if you're not able to identify that, okay, I'm talking about the names of that person. Okay, if you don't know about that name, ignore that. You don't need to have those information. You don't need to have those information. With this anonymous ID itself, we can compare that whether this person is there inside this image. Okay, whether this person is there inside this image. Look at the ID. Both of the IDs are same, right? Here, this ID and this ID is same. That means both of these persons are same. But still, we don't know the name of this person. Are you getting my point? Are you getting my point? Yes or no? Are you getting my point?
Guys, please respond.
Yes.
Yes. Sorry.
Okay.
I was talking on mute.
So here, so let me ask with some difference. What do you mean by face verification and face comparison? Can you give the exact meaning of that? What do you mean by face verification? What do you mean by face verification?
Comparing face with respect to already trained.
Can you tell like that? Oh, then what will be the face comparison?
Face
Is there,
comparison is comparing, say, two faces and try to list out the features which are similar. So the facial features that we discussed in previous line.
okay, we can do that using the face comparison. That means if we have two faces, we can compare whether these two faces are same or not using this face
Yeah.
comparison. So what do you mean by face verification?
Face verification is more like a security. So if you have kept your face as a password,
Okay, so let me give another definition for that. So
we compare
okay.
the face with a given object to identify both are identical.
Okay, so let me give you an exact definition of that. So here, thing like this, I am giving my photo to you. Okay, I am giving my photo to you, and you have my name with you. So you need to check whether this image is Nithin or not. Are you getting my point? You have my image with you, and you have a name that is Nithin. You need to verify that whether this image contains Nithin. So this is called as verification. Are you getting my point? If you're going to give it, if I'm giving with another name Jaren, then whether this image contains Jaren or not. So here verification is failed. Here verification is done in a right manner. Are you getting my point? You need to verify that.
For example, you are saying that face verification is something you are providing a name of the person and you have a photo ID of the other person A and you have given the name of the random name and it should able to identify whose photo is that, right? That's what you mean, face verification?
That given the name and the image, we need to verify that whether that name belongs to that image itself. Are you getting my point?
Okay, so you are passing two parameters, name
Yeah, I
as
am
well
passing
as the
yeah,
picture.
exactly. Yeah, I am passing this name and also I am passing this image. I need to verify that whether this image contains this, okay, whether this person is having this name or not. I need to verify that. That's the thing in verification. Verification. Comparison means we are comparing two images in order to check the similarity. Are you getting the idea? Are you getting the idea?
Not pretty clear. See, for example, I have an image. Let us assume that my image, okay, and you are going to give my name and it will tell you, I mean, it's pre-labeled, right?
Right.
It's
And
pre-labeled.
it is checking that whether that name actually corresponds to that particular person. It needs to verify that.
So it verifies all the images and it will check whether this person's image is same as the name,
Right.
whatever it is labeled
So
for.
here we are actually providing the name and the image to the system.
Got it.
So that is called as face verification. And we are going to actually do that practical. We are going to do that practical. At that time, you will be clear about that. Okay. So let me go with the next topic, that is a persistent face recognition. Persistent face recognition. So what do you mean by persistent face recognition? Thing like that, in your class, you will be having 30 participants. Okay, 30 participants. You'll be having 30 participants. And you need to design a facial recognition system. So before entering into the class, you need to stand in front of this facial recognition system and it is able to tell who you are. In order to design such a system, first of all, you need to create a group. Okay, in order to train such a facial recognition model, first of all, you need to create a group. Let's say create a person group, and in this image, you can see that authorized users is the person group. And when it comes to the case of your class, it will be the MTech. It will be the MTech class. I'm going to say like that, MTech AI batch, MTech AI batch. In that class, you will be having 30 participants. So when it compare with this image, you can see that here only 2 persons are there, Jan and Joe. But when it comes to the case of real time, you will be having several persons in that. You will be having several persons in that. And for each of this person, you need to provide some images. For example, for this first person, Jan, you need to provide some images of Jan. For this person, Joe, you need to provide some images of Joe. So what all are the main terminologies that we are using here? You need to have a person group. In that case, MTech AI, you can think like that. MTech AI is the person group. Then inside, you will be having 30 persons. And for each of this person, you need to store the images. You need to store the images of that particular person. And that will be stored inside your service. That will be stored inside your service. And we can call it as persisted phase. Persisted phase. That means it is going to store inside the service. But when it comes to the case of this, what I need to say, this anonymous ID, it is not going to be persisted in our database. It will be only exist. It will be going to exist only for 24 hours. After that, it is going to forget that. So when it comes to the case of facial recognition, we are going to save that faces. So what is the procedure? First of all, you need to create a person group, then add a person for each individual. That means you need to add each of the person to that person group. And for each of this person, you need to provide multiple phases. Okay, you need to provide multiple phases. Then it will become persistent phase. Then it will become persistent phase. If you're done with that, you can train your model. And once you train your model, you can use that facial recognition model for identifying an individual person. That means whenever you're giving an image, whenever you're giving a face image, it is going to tell who you are. With this facial recognition system, it will identify that individual person. Then it can verify the face of an individual person. That means provided the name and the image, you need to verify that whether that image contains this person or not. Okay, so you need to verify that face. And also you can find similar faces in this group. Sometimes out of these 30 persons, 2 of them are similar. You can get that information too. Okay, so using this facial recognition model, you can do all those things. So that's the exercise that we can do in this. So let me go with the first question. You can answer all these questions. Which of the following facial features can computer vision service predict? First one is age, type of eye classes, and hair color.
Age.
Age. What about others?
Age.
Age. So we can get this type of eye classes, hair color in that face service. We are able to extract that. But here the question is that they are actually dealing with the computer vision service. So with this computer vision service, we are only able to extract the age. So first one is the right option. Second option, you need to create a facial recognition solution that can identify named employees. Look at this keyword. That can identify named employees. Named employees. Which service should you use? Computer vision, personalizer, face. It's a simple question. You're going to say that. Yeah, exactly. Face is the service used for training the facial recognition system. So the first choice is wrong, second choice is wrong, third one is the right answer. Again, look at the third question. It's a super question. I like this question, right? You need to verify that. Please look at this statement. You need to verify that the person in a photo taken at the hospital reception is the same person in a photo taken at a ward entrance 10 minutes later. What should you do? You need to verify that the person in a photo taken at hospital reception is the same person in a photo taken at a ward entrance 10 minutes later. What should you do? First option, create a person group, add a person for every hospital visitor with multiple photographs to train a facial recognition model. Second option, verify the face in what photo by comparing it to the detected face ID from the reception photo. Third option, compare the age, head pose, and hair color for the faces in the reception ward photo.
Second option, sir.
Second option, what about others? So what is the key point here?
10 minutes.
10 minutes, right? 10 minutes.
You
So
mentioned ID will remain for 24 hours.
yeah, that's the exact thing. That's the exact thing. That anonymous ID will be retained in the service for 24 hours, right? So if it is given like this at a ward entrance 24 hours later, can we do that? Can we select this second option? No. What about the first option? What about the first option? Is that possible to train the faces of all the visitors coming to the hospital? No, right?
No.
It's not possible. How we can train? We are not able to train that. We are not able to. We are not able to say that who all are coming to the hospital. So we cannot go with the first option. And when it comes to the case of second option, it's the right one. When it comes to the case of 10 minutes later, if it is written like this 25 hours later, then we cannot do that. When we are not able to do that, okay, then you are not able to do that. Why? Because that face ID, anonymous face ID, will be retained only for 24 hours. After that, it will not be there. So second option is the right one. So this type of questions that you are going to get in examination, these are real-time examples. Okay, so do you have any questions? Okay, so let me discard this one. And what we are going to do is that you can see one computer vision service already created in this Azure portal, right? So we have already done that. And let me show you one simple exercise. After that, we can close the entire session. So this is the file that we are going to do, but we are not going to complete the entire exercise. Since we are not having the time for that, we can continue with the remaining code in the next class. So first of all, when we look at this, they are saying that they are going to use the computer vision SDK. Okay, they are going to use the computer vision SDK for detecting the face. From that point itself, we can say that we are only able to detect the face. We are only able to extract the age and the gender. These three information can be obtained here. So you need to install this computer vision SDK. We already installed that. So I think that, okay, let me wait. Okay, so we already installed this cognitive service vision, computer vision in our earlier exercises. We don't need to do anything there. So here you can close all those files. Let me expand this face. That is the 19th folder. Go to the Python folder. And there are two folders inside that. One is the computer vision folder and another is the face API. Two folders are there. One is the computer vision and the face API. Now we are going to expand this computer vision. So inside this computer vision, you're going to see one image folder. So inside this image folder, you can see this image. So two people are there, right? Two people are there inside this image. That's good. So this is the image. And along with that, you will be having one environment file we are talking about the computer vision service. So let me go and copy the endpoint and keys of this service. You already created that. That's why I'm using this key again. And along with that, I'm going to use this endpoint. Okay, I'm going to use this endpoint. So let me save that file. And let's go to the detect faces.py. So what they are saying, first of all, you need to load this library load_env in order to get the information from the env files. Then you need to import this pill library. What is the purpose of pill library? In order to work with these images. Okay, in order to work with these images, you need to actually install this pill library, and from there you're going to import this image and image draw module. Next is the matplotlib. This is basically used for plotting the stuffs in the images. Okay, whenever you need to plot some lines, or whenever you need to plot anything there, you can use this matplotlib. Then they are saying that we need to import some namespace. So from where we can import the namespace? Go to the AI102 page, come down. So if you're working with Python, you can copy this one. Okay, you can copy this code and paste that here. So you can do that. And here there is a space issue. So I'm going to remove that. We are going to import the computer vision client, visual feature types. So inside this visual feature types, we are providing the face information. We need to extract the face information. In our earlier example, we have detected all the features like description, tags, all those informations are extracted there. But in this case, we are actually talking with the faces. So that's why we need to extract only the face information. Then you are going to import this cognitive service credentials. Then coming down, in every files, we are going to have these codes for loading the cognitive service endpoint and for loading the cognitive service key. Then you need to authenticate the computer vision client. Okay, you need to authenticate the computer vision client. So go down. This is the code for that. Go and copy this and paste that here. So let me paste that. While pasting, please note that you need to maintain the alignment. So here we are going to create a credential object, and we are passing this endpoint and the credentials to create the CV client object. This is the computer vision client object with which we are going to work in the later code. And then what we are going to do, we are going to use this OS path.join. So here they are saying about the images and the people.jpg. So this is the folder name. You can see that this is the folder name, images. And inside that, what is the name of that image? It's people.jpg. So os.path.join means we are going to combine these images with the people.jpg. So that will become a URL. Okay, that will become a URL. And once you are able to concatenate both of these things, you're going to call a function called analyze faces. Okay, you're going to call a function analyze faces. In that analyze faces, you're going to pass this file name. That means images/people.jpg. Okay, so let me go there. And here it is going to get that file name, and it is going to print like this, analyzing that file name. Then you need to specify the features to be retrieved. Okay, what are the features that you need to retrieve? You need to retrieve only the face. If you need to have the description, you can put that. If you need to have the tag, you can put that. Okay, so in this case, we need to only extract the face information. So let me go here and paste that information. Okay, so let me go and add this features. So feature here we are adding is faces. Then after that, we need to get the image analysis. So what do you mean by image analysis? Come down, copy this file. Okay, copy this code and paste that here. And we need to maintain the alignment. Okay, we need to maintain the alignment. So read this one with open image file. We are going to read that image in the binary mode. Okay, we are going to read that image in the binary mode, and we are calling this analyze image in stream. This is the same function that we started or that we use in the computer vision module, that is in the 8th module. And along with that, you are passing this image data. This is the image, and also you're passing the features, which is the feature that we need to detect face, only this one, right? So this is the feature that we need to detect. And after that, we are checking that if there is any faces in that image. If there are any faces, in that, we are going to print the number of faces in that. So if 2 faces are there, then it is going to print like this, 2 faces detected. If 3 faces are there, it is going to print 3 faces detected. Okay, so it is going to print those information. Then if faces are there, then you need to draw a bounding box over that faces. Okay, you need to draw a bounding box over that faces. For that, you're going to use the matplotlib library. You're going to set a figure size here. You're opening that particular image. Then you're going to create a draw object. Remaining all the things are same. You're going to select a color. Here's the color we are using is light green. With this light green color, we are going to draw over that image. And for each of the faces, okay, in this analysis.faces, you're going to get all the faces. And from the list of faces, you're going to take each of these faces. And for this, each of these faces, you're going to get the rectangle coordinates. From that rectangle coordinates, you're creating a bounding box, r.left, r.top. Then you're specifying the, what is this position? Can you say that? Can anyone say that? Which is this position? This is the left top, and this is the left top, and this is the
Right top.
right top or right bottom.
Right bottom.
So when it comes to the case of image, you need to think like that. So that's the thing. When you're doing some graph or other type of subjects, at that time it will be confused. When it comes to the case of image, the top coordinate is 0, 0. That is the top left. That is 0, 0. And the bottom right is the maximum values. So here, this is the bottom right. And then you're going to create a draw object. Already we created one draw object, right? So there is no point in again doing this. Let's put comment here. Or you can actually put comment here. Okay, whatever position that you like, you can put comment here. Okay, let me put like this. I am commenting at this line. So then draw image dot draw, we are going to create a draw object, and with that draw object, we are going to draw a bounding box on that particular image with a line width of 5. With the color light green. These are the coordinates that we are passing. And you're going to say that person aged approximately face.age. This face.age is going to extract the age of that particular person, right? So you're going to create like this, person age approximately, and inside this curly bracket, you're going to specify that age of that person. And after that, you're going to annotate that. Okay, you're going to annotate that, and you're going to show that image. And finally, you're going to save that image with the name detected faces.jpg. So when you look at this directory structure, you're not able to see that detected faces.jpg inside this, right? So when we are running this file at the time, this image will be created, and inside that image, you can see all the detected faces along with the age information. And finally, you're going to save that, and you're going to get this message, result saved in output file. So let me save this file. Okay, so let me save this file. And how we can run? So this is actually inside this computer vision, right? So go and select this computer vision. Open an integrator terminal. Okay, so here you can type the command python detect -faces.py. Hit enter. So analyzing images slash people.jpg, two face detected, and the result saved in detected faces.jpg. So let me explore that detected faces.jpg. So this is the file. You can see this new file, right? So this is the file that we are able to generate. So we can directly open this face.jpg. Are you able to see this? Are you able to see this?
Yes.
You are able to see this. So what we can do is that you can parallelly do the practicals with me. So these are simple experiments. you need to know about how to effectively use this labs specified here. And I told you how to do that. And today we covered some of the topics, and I think that it sounds interesting to you. Anyway, do you have any questions for these modules? Do you have any questions for these modules?
Nithin, it's a general question from me actually. So when do we connect? Are we having any sessions planned to clarify the doubts?
So I think that for that I need to contact Shinu ma'am for that. If you have any doubts, we can have another session on 5th Saturday. And I need to check my availability too, because if some other assignments is given to me, then I'm not able to do that on 5th Saturday. Otherwise, we can take some other day for clarifying all those doubts. Or you can directly connect with me through my phone in order to clarify those things.
Okay, sure. Thank you, Nithin. Thanks for the offer.
So what about others? What about others? And my suggestion is that many of them barely done those experiments. And if you are not doing this experiment right now, then try to do and try to complete those experiments before coming to the next class. Okay. So now we are on track, and I hope that it's clear to all of you. And if you have any doubts, you can clarify those doubts at this point, or we can wind up the session. Shinu ma'am is there or not? So Shinu ma'am is not there, right? Okay. So what's your opinion? I need to get opinion from you too regarding this course. Can anyone unmute your mic and say regarding this? So what's your opinion about this course?
You can judge us after giving the exam.
Right. So one suggestion is that after going through this MS Learn, try to go through the Microsoft documentation too. Okay, try to go through this Microsoft documentation too, because they are going to ask from everywhere. They are going to ask from everywhere. So basically, they are giving some modules in this MS Learn, and we need to first of all clear all those things in that MS Learn. After that, go and search more about those specific topics in Microsoft documentation. So that's the strategy that we need to take. So while I'm taking the exam, I'm doing the same strategy. After going through the entire MS Learn and after completing all the labs, I'm getting confident regarding each of these topics. But when doing the practice test, I'm seeing some new questions. At the time, what I'm going to do, I'm actually searching for that particular question. So in order to get the answers for that particular question, I need to read the Microsoft documentation. So practice test is highly important. Okay, practice test, and also you need to go through this documentation. So that's my suggestion. You can follow up those things, and you can utilize this 1 week for learning these 3 modules. In your case, you're too lucky, because in between you're getting 1 week, right? So when we are taking this corporate training, this 4 days will be continuous. At that time, so many things, these guys are getting so many technologies, and in their head, they are sometimes they are being confused about what exactly this one and this one, right? So you're going to grasp so many things there. But in this case, you're going to get some time in between these sessions. That's an advantage for you. So utilize those advantages. And that's all about for today's session. And I hope that we can meet in the next Saturday. We can meet in next Saturday. So thanks for listening. And if you have any queries, you can directly text me or you can call me at any time. I will be available for you. Okay. So have a nice day, and bye then.
Thank you.
Thank you.
Thank you.
Thank
Bye.
you. Thank you.